Okay, today our objective is to be able to determine the percent yield given various things. We're going to work two examples here today, and one of the examples you will be given a actual value. The second example, you will be given the percent yield. So we will have to work it a slightly different way, somewhat backwards of the first one. So the percent yield is the actual yield divided by the theoretical yield multiplied by 100. So the very first example, I'll give you a second to write it down. Once you write it down, take out your reaction prediction help sheet, because we have to come up with this reaction. The question states, what is the percent yield if 125 grams of sulfurous acid is produced when 128 grams of sulfur dioxide combines with excess water? Now, if you look at your reaction prediction help sheet, this is a single, actually this is not, this is a combination reaction. So, if we have a non-metal oxide in water, it gives us an oxyacid. So this is combination reaction number 2. So our oxyacid being formed here is sulfuric acid. Our non-metal oxide, SO2, combines with excess water. That's important. So we already know what the limiting reagent is. It is sulfur dioxide. And it's going to give us sulfurous acid. I see an O-U-S there. So it is sulfate, or excuse me, sulfite, H3S, or H2SO3. So sulfur dioxide, SO2, plus water yields H2SO3. That equation is balanced, correct? Now, I have been given an amount of sulfurous acid right here. Okay? That much sulfurous acid is produced. Okay? When I go back to this page, that is my actual yield. That is how much that was actually produced. I need to come up with my theoretical value. How do I do that? I'm going to take my mass of sulfur dioxide, okay, 128 grams of SO2, and I'm going to go mass to mass to sulfurous acid. Okay? I'm going to go mass to mass to sulfurous acid. So, (64.03 or 0638 grams of SO2 is 1 mole SO2. My grams of SO2 cancel. I've converted that to moles. I look at my molar ratio. 1 mole of SO2, 1 mole of H2SO3. My moles of SO2 then will cancel. Now I have to do mass of H2SO3. So that's 82.07408 grams of H2SO3. That's going to be 1 mole H2SO3. So my moles cancel, my moles cancel. We've done mass-to-mass reactions. So I do my calculations, and I came up with 163.98 grams of H2SO3. Now notice that I have not sig figged this yet. I don't want to round it until I have completed the problem. I have not completed the problem, so I am not going to round yet. Now, I've got my theoretical yield that I just calculated, okay? So, I'm going to take my actual yield, which is 125 grams. My theoretical yield was 163.98 grams. Multiply that by 100 to put it into a percentage. And now I'm going to sig fig my value to 3 significant digits, 76.2%. Now, what does the percent yield tell me? What is this telling me? It's telling me how close I am to the actual value that I theoretically could have got. Do you think that every time we do an experiment that we get exactly 100% of the products that we should have got? Okay? It's not going to happen. Just doesn't happen like that. We're not that accurate. So, percent yield tells us how close we are to what we should have got. Now, if you're doing something like a very, very valuable metal, okay, let's say you're doing a single replacement of something to get copper. Copper's pretty expensive. All right, would you want a high percent? Yeah, because the better your percentage, the more money you're going to get from that copper. So you're going to want high percentages. That is what